Hey guys, we are going to do section 4 of chapter P, and it is called inverse functions. I don't think you do much of inverse functions in Algebra 1. You definitely would have learned them in Algebra 2 in some capacity, probably talked about them in pre-calc, but we'll just review inverses. You'll learn them from top to bottom. Think inverse is an opposite in some ways. Inverse functions do usually use some sort of opposite operation in one capacity or another. All right, so a function g is the inverse of a function f. Those are just their names in function notation. If f of g of x is equal to x. So that implies a composition of function like we talked about last section. Okay, so g of x is in f of x. And g of f of x, it should have also equals x. That's a typo on my part. All right, so g of x, if that is true, then g of x would be considered the inverse of x. And that is this -1. That's not f to the -1. That is read as f inverse of x. Okay, so a function has to be 1-to-1 for an inverse to exist. So we talked about 1-to-1 and onto last section. In order for an inverse to exist, it has to be 1-to-1. In order for it to be a function, it has to be onto. Okay, so we're just talking about it being, these will be functions that we are dealing with. We won't be dealing with something that's not a function for this section. So we really only have to worry about 1-to-1. Easy way to tell 1-to-1 is picture the graph, sketch the graph, put it in your calculator, look at the graph. And for an inverse to exist, it has to pass the horizontal line test, which again, for example, is if I look at a graph and say I have a parabola opening to the right, it's going to fail or fail the vertical line test is not a function. But if I have a regular parabola, it fails the horizontal line test. So it also does not have an inverse with that domain going from -infinity to infinity. So we can restrict the domain, though, in order to see an inverse. You'll see restricted domains on some of your homework assignment. Those will look like that set notation. For example, like -1 is less than x is less than 1. Okay, they'll do that domain. It might exist in that domain. So the inverse of this parabola that I drew on the right would exist if I just looked at, say, just the right half or just the left half. I just can't look at the entire function. All right. One cool thing about inverses is they are the reflection across the line y equals x. So if you picture, say, just a right half of a parabola, so let's just do y equals x squared when x is greater than or equal to 0. So we'll restrict that domain so it does pass the horizontal line test. And if we do that, then if I were to reflect across the line y equals x, which is a line that has a y-intercept of 0 and a slope of 1, if you were to graph it in y equals mx plus b form, then it would mirror here, which is actually the graph of y equals root x. And x has to be greater than or equal to 0 for be a square root function to work. And so that would be an example of reflecting across that line, y equals x. You might see some of those. All right, we're going to show the functions are inverses of each other. So again, if you back up and look, we have to do f of g of x and g of f of x. You don't get to just do one side because certain things can pass on one side and fail on another side. Okay, so we will do it on both sides. All right, so show the functions are inverses of each other. So first what I'm going to do is f of g of x, which means I'm going to go plug in the g function everywhere there's an x and f function. So I'm going to do 2 instead of x. I'm going to do the cube root of x plus 1 all over 2, excuse my terrible handwriting, minus 1. So I just replaced this x with this whole function. Okay, and I'm actually going to undo those 2 circles so that I don't have them there later. All right, and then I just simplify it. Okay, cubed and a cube root, those are inverses of each other, so they do cancel. So that would get rid of those. So I have 2, and then I have x plus 1 over 2 minus 1. You have to show your steps of simplification. I know you can simplify things in your head. You guys are very smart. I want to see it. It's almost like not almost like it is an algebraic proof of why this works. Our end result should be x. All right. Left my parenthesis off there. And a 2 on top with a 2 on bottom, if I were to distribute that through, it cancels because I have a multiplied 2 on top and a multiplied 2 on bottom. So that leaves me with just x plus 1 minus 1 leaving me with just x. So it works on this side. We'll go and do it on the other side. Good practice for algebra skills too. So I have this g function, the cube root of x plus 1 over 2. But in place of x, I'm going to put my f function. So this whole thing. So 2x cubed minus 1, but I can't forget that plus 1 that's also in the top. So extend that out. All right, so then I'll simplify it. My plus 1 and my minus 1 cancel. Okay, so I would have the cube root of 2x cubed over 2. The 2's cancel, leaving me with the cube root of x cubed, leaving me with just x. So those little check marks just say I verified it. When you see the word show implies it will work out. Okay, if it said prove, it also will work out. If it said determine, that could be a yes or no. It may work out or it may not work. So determine if these are inverses of each other. That might fail, might pass as well. Show will work out. So that's a way to kind of check yourself. You keep getting it not working out, you know you've made an error. So which of the following has an inverse? Again, if you go back to that slide we talked about, in order for an inverse to exist, it has to be 1-to-1. So we're looking at, are these 1-to-1? Do they pass the horizontal line test? These are often easiest to just graph. And you can kind of look at the graphs of these. They're not too bad when you do that. So if I look at a graph of the line x minus 1, the line x minus 1 would have a y-intercept of -1. It would have a slope of 1. And so I'm just going to have this slant here. And then do they pass horizontal line test? Horizontal, 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 infinitely many horizontal lines. And yeah, it does pass. And so which of it has an inverse and exists? This one does have an inverse. So I'm going to explain why it has an inverse. It passes the horizontal line test, so an inverse exists. Inverse exists. Okay. All right. And then the next function is a cubic function. So in general, a cubic function is kind of curvy shaped. So if we were to look at this graph, it could help to do an XY chart and figure out where some of the values are. Or you can put it in your graphing calculator and you can look at where those values are. In general, I like to do -2, -1, 0, 1, 2. And then if I don't get the shape I know I'm supposed to get, then I can plug in more values. So if I cube -2, I get -8. And then I minus -2, I get 6. And then I add 1 and I get 7. I'm going to do the same thing for -1. If I do -1 cubed minus -1 is 0 plus 1 is 1. And then 0, I get 1. And 1, I get 1 cubed minus 1, which is 0 plus 1, which is also 1. Right? Yeah. Okay. And then I plug in 2 and I get 8 minus 2, which is 6, plus 1, which is 7. That doesn't seem right. Should that one be negative? That's -7. Okay. -1. Double check my math. Yeah, that's good. Okay. So then if we look at that, we graph that at 1, and we don't have to go all the way to 7. We can kind of just look at this -1, 0, 1, because I don't want to make my graph that big. At 1, it is 1. At 0, it is 1. At -1, it is 1. And if you look at your graphing calculator, it does have a little bit of a curve thing going. And so it goes up and down and up. But what matters is the fact that all these are 1. It fails the horizontal line test right there. Fails horizontal line test. So no inverse. On that domain, since I didn't restrict the domain, there's no inverse there. All right. So pause real quick because my dog is a psycho. All right. How to find the inverse of a function. All right. For some reason, I think this is great fun. So hopefully you guys enjoy it just as well as I do. We are going to determine if an inverse exists. First, you can't find an inverse if it doesn't exist. A lot of times it just takes a slight evaluation of looking at the graph, kind of like we just did. If it does, we're going to trade our f of x value we're going to replace it with y. So it's y equals instead of f of x equals. If it already does that for you, it gives you a y equals, then you're done with that step. The step 1 is already done for you, except for determining whether the inverse exists. Then we're going to trade our x and y values for each other. So in place of x, I put a y. In place of y, I put an x. Okay, so that equation would be x equals instead of y equals. Then we're going to solve for y. So we're going to solve it all over, and then we're going to rewrite it as f inverse of f inverse of x. So a reminder that this -1 does not mean a power of -1. It means inverse. All right, and then we verify our results to check it, which we will plug them into each other. Okay, so hopefully I have enough room for this. So I'm going to rewrite this as y equals root 2 x minus 3. And then I'm going to, that's step 1. And we need to look at the graph too. So if you know what this square root function is, we talked about it earlier, it is a function that starts here and goes here. So if you look at those transformations, what has happened to it is it has moved right 3, and then it's had a vertical change of 2, okay, or horizontal change of 2. So it's going to be made stretched out. And so that doesn't affect where the fact it's going to change its shape in general. It's going to still pass the horizontal line test no matter those shifts that go on. Okay, so it is 1-to-1. And we did step 1. So that's all step 1. Step 2, okay, we're going to trade x for y. So x equals, instead of y equals, root 2. Instead of x, we're going to put y minus 3. And that's it for step 2. And then solve it. So then we're going to get rid of anything surrounding the y, so we get y equals. So first thing I'm going to do is square both sides so that I get x squared equals 2y minus 3. Did that because the inverse of root is 2. All right, then I'm going to add 3 to both sides so that an added 3 will cancel theirs out. And then I'll divide both sides by 2. Okay, so that I have y equals x squared plus 3 over 2. Step 3 is to just rewrite it as f inverse. F inverse of x is equal to x squared plus 3 over 2. To verify, I'm going to plug them into each other. So f inverse of x is equal to root 2. In place of x, I put the function I just found because that is my inverse. Okay, so in place of x, I will have x squared plus 3 over 2, and then that minus 3. And then I just simplify it. So the 2's cancel. Okay, the x squared minus 3. Oh, that should be a plus 3. Can't read my own handwriting. Minus 3, and the 3's will cancel. And I still have my square root. And then the square root of x squared is just x. Okay, and if we verified on the other side to save some time on this thing, you would also get x whenever you plug that in. What that would look like is f inverse, we won't do the whole thing, of f of x. So we would have, instead of x squared, we would have root 2x minus 3 all squared plus 3 over 2. And you would simplify that, and your end result would also be x. Okay, so this is a big table. I don't know if you want to screenshot this table. This table comes straight out of your textbook as well, so you don't have to do that. But it's an important one. So arc sine, arc cosine, arc tangent, arc cotangent, arc secant, arc cosecant, what those are saying is that is the same thing as saying this is sine inverse. This is cosine inverse, tan inverse, and so on and so forth. Those are synonymous for the same thing. So depending on what you're going to do after high school, you may end up taking more calculus classes. Those are the same thing. Okay, and depending on the textbook and depending on the teacher will be what you use for that. So just know that arc sine is the same as sine inverse and all the way through. They've restricted your domains again to make sure. So if we're talking about arc sine, this is the domain that works for arc sine. This is the range that works for arc sine. Those are going to be really helpful in some of your homework problems. So it might be good to either write this down, take a picture of it on your phone, some way that you can access it with your homework so that you maybe don't have to flip back and forth. But you'll need this to be able to find things because they won't just tell you the domain. They're going to assume you know the domain because they already informed you of the domain. You're not expected to memorize these domains, except for it would be important to maybe do sine and cosine. They're going to be very, very common domains and ranges that you're going to use. Okay, and again, these are all reference on domain as your input. So we're talking about your x values, and range is your output. So we're going to be talking about your y values. Okay, all in reference to the unit circle. Okay, so we are going to evaluate each expression. So again, these are asking for the inverse. When it's asking for the inverse, it's asking you what angle value gave you that number. Okay, because regular sine is sine of an angle. So sine inverse is the opposite of that. It's what angle gave me a -1/2. So what I'm going to do is I'm going to do a rough sketch of my unit circle just to kind of help me out. So I'm looking at a -1/2. Okay, and it's talking again about sine. Remember, it is cosine, comma sine for our ordered pairs. Okay, so that'll be helpful. So we're looking at y value that would have a y value of -1/2. So y values are only negative when they are down here and they are down here. Okay, so I've got to figure out where that's going to be. And in order for sine to be -1/2, we've got to consider the domain. So again, the domain for sine is -1 to 1. Okay, and the range is -π/2, -π/2. So since they're talking about what was the angle, it's talking about range, okay, because that was what you're getting. So we're looking from just here to here, okay, in that. So I will ignore this one. So I know it has to be in that quadrant there. And so we're talking about -1/2. -1/2 always goes with √2/2. Nope, sorry, √3/2. And so we've got to consider where that would be. So -1/2 is smaller than √3/2, okay, which would mean it's a skinnier triangle, okay, for the sine side of it, for the y side of it. So it's not going to be as deep for the y side of it. So that's going to be over here, okay. If you think about where that would be at, that's the opposite of here, okay. This is π/6. So this would be -π/6. Or you could do 2π minus π/6, but again, that's not within the domain. The domain or the range was π/2 and π/2, -π/2. So you're not going all the way around, you're going up and down, so positive and negative. So the answer to this would be -π/6. Keep that in mind. If I go backwards around the unit circle, I can use negative values. Okay, think of it almost like a number line, but it's a circle. All right, cosine of 0. Okay, so we have to figure out the output has been cosine of 0. What angle gave me cosine of 0? Well, cosine is the x values. So your x values are 0 here and here. If I go to my domain, okay, and my range for cosine, it's 0 to pi. So it's actually only from here to here. So I'm not going on that bottom half. Okay, this over here is pi. So cosine of 0 is going to just have to be here. What angle is that? That angle is π/2. Again, memorizing that unit circle will be really, really helpful. Okay, and then tangent to be √3. Okay, you have to consider where √3 would be. √3 is never for a π/4 angle because it's √2/2 and √2/2, and tangent is sine over cosine. So there's no getting that. That's going to end up being 1. Tangent of 45-degree angle is always 1. Okay, or -1 if you go around the circle more. So if we go look at our range for tangent, it is -π/2 to π/2. So it's the same one we used for sine. So it's here, back over here is what we're looking at. And we're looking at things that result in √3. So if I think of this as sine over cosine, okay, and I'm getting a result of √3, which means that 2 would have had to have cancel out. So I'm going to have a √3/2, because it's never just √3, over something that would cancel that 2 out. If I divide that by 1/2, which is the other option, okay, dividing by 1/2, you could multiply by the reciprocal. Okay, that divide by a fraction, you multiply by the fraction flipped, and that would result in √3. So the reason to do that is to kind of figure out what fractions we're dealing with. So at what angle is sine √3/2 and cosine 1/2? Okay, well, we kind of helped ourselves out when we did sine of 1/2 we got here. So how to get sine over root 3 over 2, it's going to have to be here. And again, one way to help that out is sine is the y value. If you notice how much taller that is, it's going to be the bigger value. Root 3 over 2 is bigger. This ordered pair, if you go back to the unit circle we reviewed last section, this ordered pair is 1/2 comma root 3 over 2. What angle is that? That angle is pi over 3. Okay. This one, 0.3, nowhere on the unit circle. What you're going to do is plug it in your calculator. Your calculator does not have arc sine necessarily as a button, but it does have a sine inverse button. Usually you have to shift and click sine. So you're actually going to type this in your calculator. And then one thing, I don't think I mentioned it in AP Calculus, you need to round to 4 to 5 digits. Okay. So you want to take it pretty far out. And so when we plug this in our calculator, we get 0.3047. Okay. Again, that unit circle is really important. If you're struggling with the unit circle, there's so much help on the internet, YouTube videos, little tricks to memorize it. You're going to have to memorize it or memorize how to find it. Okay, again, I don't have it memorized. I only have the first quadrant memorized. All right, we are going to now solve this equation. I feel like I'm missing something because it's not equal to anything. It's supposed to be equal to pi over 4. All right, we're going to solve arctangent of 2x minus 3 equal to pi over 4. The goal, again, if you're solving it, you're trying to get x by itself. So I got to get rid of arctangent. Again, that's tan inverse. It helps me. You do not ever have to write this step out, but because for the past 10 years of my life, until we got this new textbook, I use tan inverse written with a -1. And so it's hard for my brain to do the other. So I rewrite it like this because it reminds me, if I want to get rid of something, I'm going to use the inverse. The inverse of tan inverse is just regular tan. So I'm going to actually take the tangent of both sides. What I do to one side, do to the other, just like you would if you're dividing both sides by something, multiplying both sides by something. And that will actually cancel that out, just like it would if I were dividing or multiplying something that had been done the opposite with. Leaving me with 2x minus 3 equals tangent pi over 4, which we actually can calculate tangent pi over 4. We actually talked about it. Again, your unit circle, if you go here where pi over 4 is, that ordered pair is root 2 over 2 and root 2 over 2. And sine over cosine, you're going to get 1. Okay, so I will have 2x minus 3 equals 1. Add 3 to both sides, and I get 4. Divide by 2, and I get x equals 2. It's not any different solving a regular equation in algebra. The only difference really is that you have a new operation that you're not used to. All right, so we are given here a range where 0 is less than y is less than pi over 2. It's a way to read that would be y is between 0 and pi over 2. We're going to find the cosine of y. Okay, it looks like I spelled cozy wrong, but I didn't. So we're going to find the cosine of y. So why this is helpful is it tells you what values are. So if we are finding the cosine of y, we are, again, missing something. I'm sorry for all my typos. We're also given, so make sure you're paying attention to that in your notes. We're also given y equals arc sine of x. Okay, that's really important because we need that given information. If you look down at the bottom, it gives us that. The range is just helpful because it tells us where our parameters are. All right, so we're given that y equals arc sine of x. Okay, why that is important is that tells me that the inverse is, again, what's my angle? It tells me my angle is y. So I'm going to pick one of my angles. I'll just pick this angle to be y. I have these blank right triangles. Trig functions are for right triangles. Have relationships to right triangles. And so I put them on there to help us out. So you may, if you're writing notes down in your notebook, you may want to draw little right triangles. So that tells me the arc sine of x is y. Well, sine is opposite over hypotenuse. So in order for us to get x as my opposite over hypotenuse, it would have to be x over 1. Okay? That's the only way to get x. It would be x divided by 1. Okay? And then I can actually use Pythagorean theorem, if you recall that from 8th grade, Algebra 1, geometry, hopefully Algebra 2 a little bit, pre-calculus. It's just one of those formulas that doesn't go away. And I can actually solve for the missing side, and I can actually find it. So I will do x squared plus b squared equals 1 squared. And I will solve it. So b squared equals 1 minus x squared, square root both sides. So this side has to be 1 minus x squared. Okay, and then it says, so find cosine of y. Well, that's not hard. Again, cosine of my angle. Just remember what cosine is from geometry and pre-calc. Cosine is adjacent over hypotenuse. Adjacent to the angle is root 1 minus x squared. And the hypotenuse is 1. So it's just root 1 minus x squared. So it's almost like a puzzle. Same thing here, okay? I gave you all the information this time. And we have y equals arcsecant, so the secant inverse of root 5 over 2. Again, y is my angle. You can pick any of these angles. Let's just switch it for fun to be y, okay? Secant, if you remember, is 1 over cosine or cosine flipped, okay? So if this is cosine flipped, instead of being adjacent over hypotenuse, it's going to be hypotenuse over adjacent. Okay, that's how secant's going to work. So my hypotenuse has to be root 5. Okay, and my denominator would have to be root 2. Okay, in order for it to be adjacent, adjacent would be here. All right, so then we would have to figure out what the other side is in order to tangent, because tangent is opposite over adjacent. So I'll do my Pythagorean theorem. Well, root 2 squared plus mystery squared, we'll use b again, equals root 5 squared. So then I will have 2 plus b squared equals 5, and I will have b squared equals 3. And so b equals root 3, so this is root 3. And then I will do hypotenuse over adjacent, tangent. We'll do opposite over adjacent. So opposite over adjacent for tangent of y equals root 3 over root 2. Rationalizing the denominator is important. Roots don't really belong in the denominator unless they don't give you specific directions not to. For the sake of we are trying to review everything, we should rationalize this. So I'll multiply top and bottom by root 2, and we will have root 6 over root 4, if you think of it that way. And you don't ever have to write that step because you are all smart enough to simplify that in your head. And root 6 over 2 would be the correct answer for that. All right, that is the end of your notes. I will be posting your homework assignment. Make sure you're doing that. Some of you, I think Cami is having a hard time. Just be patient and if I ask you to repost it, just repost something. Try your best to always save things that are going on. I know it's supposed to automatically save, but always double check to make sure it says saved at the top. And just resubmit it when I ask and resubmit it when I ask, because I need to see that your work is coming in or I can't give you credit for it. Most of the homework assignments, the answers are on the back of the book. So please be checking your answers, but I can't give you credit for things that a 5-year-old could copy out of the back of the book. I need to see that you are the ones doing it. So please make sure you go back and put work when I ask, and just be patient with Cami as it's not always working, and you may have to try it at school versus try it at home internet. I don't know which internet will work or if it's the program itself. But I hope you guys have a good week. This will be the only video we are doing this week since we have a short week. So you need to be looking towards having a test next week. That'll be your first big grade. We've been doing our homework assignments. Overall, I'm very impressed with your guys' homework. So just keep it up and just keep showing me your work. And if you guys need to work together, there's ways for you guys to contact each other. But again, you can always contact me. All right. Hope you guys have a good week.